Again to all my dear students. Hope you all are good and taking good care of yourselves and concentrating on your studies too. So let us begin with today's discussion of the chapter metals and non-metals, which we had started in the previous week only. So the chapter, as I told you, that it is the metals and the non-metals, and we have already discussed about the first topic, and that is the physical properties of metals and non-metals. So on your screens, you would be able to see few of the general physical properties of metals, non-metals, and metalloids, which have been discussed earlier only, are visible, in which it is there that metals are generally shiny and ductile as well as malleable. You can add on over here. They are the good conductors of heat and electricity too. Similarly, for the non-metals, they can be said as to be the dull, brittle, and poor conductors, and at the same time, they are also the good insulators. For metalloids, which have the characteristic properties of metals as well as the non-metals, they are the better conductors than non-metals, but not as good as the metals. So, if you all remember, I have already told you that the metalloids are generally used as the semiconductors and the insulators wherever it is required. So now we are going to talk about the next part of the chapter, and that is the characteristics and the reactions of metals and non-metals. So I hope everyone is ready to learn this thing. So when I talk about the non-metal, let us discuss few of the things. How do we get to understand that the given element is a non-metal? Apart from knowing their physical properties, there are few of the things which you need to know so as to identify a metal or a non-metal. So this is a chart which is talking about the non-metallic group, which are lacking most of the properties of metals, and we find that there are a total of 17 non-metals, and many of the non-metals are very common elements and extremely important to all the living organisms on the earth. So as we have already discussed about the state, that generally the non-metals are found to be gaseous at room temperature, and that is why their density is found to be very less as in comparison to the metals, and at the same time they also have the low boiling points. Next point says that the physical properties of non-metals are obviously opposite to that of the characteristic metals. So the last point is again saying they are dull, not malleable or ductile, poor conductors, and when in solid form, they are brittle. I hope everyone remembers here the meaning of brittle. I'm just reminding it once again that the brittle means that if you are hammering it, that substance is going to get broken down into smaller pieces. So it is not going to get formed into the thin sheets. So this property in which the substance is getting broken into smaller pieces, it is termed as brittleness, and the substance is said as to be the brittle. Now this is an important part here. Now whenever we talk about the chemical property and we try to compare it with the metals and the non-metals, this is something which you have been studying from so long, and in class 9 it has been discussed also in detail in the chapter structure of atom. So if you do not remember that, let us recall it very quickly once again. So if we talk for metals, we find that generally the metals contain 1, 2 or 3 electrons in their outermost shell, which is also termed as valence shell of the atom of that particular metal. So here if you can see the example, that is the sodium atom. Here you can see there is presence of 11 protons and 12 neutrons. It means that the atomic number of sodium is 11 and its atomic mass is 23. So as per 2n square rule, you will find that it has got the electronic configuration or electronic arrangement as 2, 8 and 1 electron, which means the outermost shell or the valence shell contains just 1 electron, and therefore we understand that the sodium atom or sodium as an element is a metal. Similarly, when we talk about the non-metals generally have 4, 5, 6 or 7 electrons in their outermost or the valence shell. So exceptional cases here would be hydrogen and helium. So hydrogen, because it is having a tendency to release the electron as well as to accept the electron. It has just one electron in its outermost shell, but it may also go for gaining of the electron or losing of the electron. So it is not included in the metal or the non-metal completely. Same ways when we talk about helium, helium contains 2 electrons in its valence shell, and therefore it is considered as the noble gas here. So example here is of chlorine, in which there are 17 electrons, and therefore the arrangement of the electron is as 2, 8 and 7, which means there are 7 electrons in its outermost shell, which is one of the characteristic feature of the nonmetals. Similarly, when we talk about the ion formation is simply what? The appearing of any charge on any of the atom, whether it is positive or negative. How come we decide whether it is a positive charge created or the negative charge? It is simple. How can you remember? If any atom has lost the electron or donated the valence electron, it forms positive ion, and it will acquire those many number of positive charges what it has lost in the form of electrons, which means, like for an example, that sodium here has lost this one electron which was present in the outermost shell to obtain its octet or to fulfill its octet and become more stable. So therefore when it loses one electron, there is a creation of one positive charge because the electrons are now less in the ion as in comparison to the proton, which are already 11. So in the sodium ion, the number of protons are 11, whereas the number of electrons are just 10, and therefore the overall charge which appears on the sodium atom is +1. Same ways, the nonmetals have a tendency to accept the valence electrons and form the anions, which is the negative ions. So when chlorine accepts one electron, it gets one extra electron in its atom, and therefore this extra electron, which contains a negative charge, appears in the form of -1 charge, and this becomes the ion which is called as chloride ion. Just remember, this is not chlorine ion, it's chloride ion. So that is how we can understand that how the metals and the non-metal show these basic chemical properties of formation of ion. Now let us see the chemical properties of metals now. Once we have got to understand that how can we differentiate a metal from a non-metal based upon the electronic configuration or the number of electrons possessed by it. So the very first reaction what we are going to discuss today is the reaction of metals and the non-metals with oxygen. In this we will talk about certain examples so that you are able to understand the reaction, how is it happening. So if we talk about the reaction of metals first, metals react with oxygen to form metal oxides. So when copper is heated, like this is an example, when copper is heated, it combines with oxygen to form copper oxide, and the reaction you can see here that copper Cu is reacting with oxygen, and then it is copper oxide, a black colored substance, that copper oxide is black in its color, and copper is a you can say a brownish or brownish color metal, which on getting heated, it forms a black colored oxide or a substance called as copper oxide. Similarly, when we heat aluminium, it combines with oxygen to form aluminium oxide with having the formula Al2O3. Similarly, some metal oxides are basic in nature because they react with water to form the bases. So, like, let us take one example first of all. Sodium, which is one of the very highly reactive metal, and it undergoes reaction with oxygen even at the room temperature. So, when it reacts with oxygen, it leads to the formation of sodium oxide. If we want to test the nature of sodium oxide, what should we do? We should dissolve the sodium oxide in water. Now the question arises that why are we choosing water for its dissolution or for dissolving it? The answer is that water is a neutral compound, and because it is a neutral compound, it does not has its own nature and will be able to tell the nature of the substance which has been dissolved with the same. So, therefore, when we dissolve sodium oxide with water, we find there is a substance form which is called as sodium hydroxide. And with the help of any indicator, maybe the litmus paper, we find that the red litmus paper turns blue, indicating that sodium hydroxide is basic in nature. And since sodium hydroxide is basic in nature, we can easily say that sodium oxide is basic in nature because water was neutral. Similarly, if we want to talk about potassium, potassium when reacts with oxygen leads to the formation of potassium oxide having the formula K2O. Now in this case, same ways if we want to identify the nature of potassium oxide, we have to dissolve it in water. Then we find that it is potassium hydroxide, which is basic in nature, and therefore we can say that the metal oxides mostly are basic oxides because whenever they are dissolved in water, they form the corresponding bases. Now there are few of the metals which form the oxides which may be acidic or basic in nature, and these kind of metallic oxides are called as the amphoteric oxides. So you need to remember this term very properly. Amphoteric oxides are kind of neutral oxides, which means that if they are allowed to react with a base, it behaves as an acid, and if it is allowed to react with the acid, it behaves as a base. So here there are a few of the examples such as aluminium oxide and zinc oxide, which are the amphoteric oxide, which means as, like, in aluminium oxide, if we allow it to react with hydrochloric acid, which is an acid, it will behave as like a base because it will form salt and water. So if you can recall the first chapter wherein we have discussed about the acid base reaction, it leads to the formation of a salt along with the water as a molecule over there. So when the same oxide, which was initially basic in nature, which was showing the basic characteristic, when it is dissolved in sodium hydroxide solution, which is a base actually, then again we find that there is a salt formation called as sodium aluminate, NaAlO2, that is the salt sodium aluminate, along with the release of water molecule. So since again salt and water is formed, this can be verified that it is acidic in nature in this particular reaction. Same ways if we talk about the zinc oxide, if zinc oxide is allowed to react with hydrochloric acid, it will form zinc chloride and water. Then in this case it is acting as a base, whereas if zinc oxide is dissolved in sodium hydroxide solution, it will form sodium zincate salt. So therefore again along with water, so in both these cases we find that the same oxide shows acidic as well as the basic properties, and therefore they are called as amphoteric oxides. So when we have to summarize this reaction of metals with oxygen, that we find that almost all the metals react with oxygen to form metal oxides. But yes, there is a differentiation, or there is a um, difference in the reactivity pattern of the different metals. Few of the metals may be highly reactive, few of them may be moderately reactive, and few of them will be the very less reactive, which will require a lot of ignition for their reaction to get initiated. So when we talk about sodium and potassium particularly, they're the most reactive metals, and therefore when we keep sodium even at room temperature, it reacts with air to form sodium oxide. And therefore this is very important that you remember here that sodium has to be stored under kerosene oil so that it can be prevented from its reaction with oxygen, moisture and carbon dioxide. Because it is one of the very highly reactive metal, it will be able to react with anything which is present in the atmosphere at a very high rate. So this is again a reaction with oxygen for the metals. Let us take one more example here, that when magnesium reacts with oxygen forms magnesium oxide. And if we want to check the nature, it's again the same process of dissolving magnesium oxide, which is white colored powder. And I hope everyone remember that magnesium is available in the form of magnesium ribbon in the labs, and when it is burned it gives a white dazzling light, and then after when this reaction is completely done, it forms a white colored powder, which is the magnesium oxide. So when we dissolve this magnesium oxide powder in water, we find it forms the magnesium hydroxide, which is a base. Now when we talk about the non-metals react with oxygen to form the non-metallic oxides. As like metals reacted with oxygen to form metallic oxides, the non-metals react with oxygen to form the non-metallic oxides. And generally we find that these non-metallic oxides are acidic in nature. It's not like all non-metallic oxides are acidic in nature, but yes, that most of the non-metallic oxides are acidic in nature. And how do we confirm this thing? It is just again the same process, that we are going to dissolve that non-metallic oxide in water and then test its nature. So let us take one example. When sulphur, which is in the form of yellow powder, when it is burnt in the presence of oxygen or air, it leads to the formation of sulphur dioxide. And when this sulphur dioxide gas is collected and it is made to get dissolved in water, it leads to the formation of sulfurous acid, which is H2SO3. And when we test the nature of sulfurous acid, we find that it is able to turn blue litmus to red. So that is how we can confirm the nature of the oxides for the non-metals as well. Now, these are the two examples which are the most common examples. When sulfur reacts with oxygen to it forms sulfur dioxide, and at the same time when carbon is reacting with oxygen forms the carbon dioxide. Although there are certain important things which you all need to remember when it comes to the reaction of non-metals with oxygen. Unlike metals, the formation of non-metallic oxides are multiple in number. It means like when sulfur is reacting with oxygen or carbon is reacting with oxygen under different conditions of oxygen level, means whether it is present in the limited quantity or it is present in plenty or unlimited quantity, there will be the formation of the different oxides. So when I talk about sulfur, in the limited quantity it will be sulfur dioxide, but when there will be unlimited quantity of oxygen, it will lead to the formation of sulfur trioxide, which is SO3. Similarly, when we talk about carbon, when carbon is reacting with oxygen under limited oxygen content, it leads to the formation of carbon monoxide, which is having the formula CO. Whereas when carbon is reacting with oxygen under plenty of oxygen, it is forming the most common product, which is carbon dioxide. Now, here you can see the reaction of nitrogen with oxygen. Here I have shown you two of the oxide formation, and there are multiple number of oxide formation when nitrogen is reacting with oxygen. So one of the oxide here you can see is the nitric oxide and another is the nitrogen dioxide. So nitrogen initially, which is N2, reacting with oxygen forming nitric oxide, which is having the formula NO. Now this nitric oxide may further go ahead with reacting with oxygen and leads to the formation of nitrogen dioxide. So it depends upon under what condition the whole oxide formation or reaction of these non-metals with oxygen is going on, and accordingly there will be the different kind of oxides which will be formed and we will be able to obtain them. So in this slide you can see there are multiple number of nitrogen oxides which are given along with their formula as well as their bond structure. So the very first is the nitric oxide, which is represented as NO. Then after we have nitrous oxide, which is the formula having N2O. Then after we have nitrogen dioxide, the most common one, which is NO2. Then we have dinitrogen trioxide, N2O3. We have dinitrogen tetraoxide having the formula N2O4, and at the last we have dinitrogen pentaoxide, which is N2O5. So these are the 5 major oxides which are formed under different conditions of oxygen availability, starting from nitric oxide, the nitrous oxide, nitrogen dioxide, dinitrogen trioxide, dinitrogen tetraoxide, and dinitrogen pentaoxides. So in non-metals, the peculiar thing which you will have to remember that they are mostly forming the multiple number of oxides, and these oxides generally are acidic in nature, but they may also be basic, or they may also be sometimes neutral in nature. So if I talk about few of the examples of acidic oxides of non-metals, it can be carbon dioxide, because when we are dissolving carbon dioxide in water, we find carbonic acid is formed, which is H2CO3. Similarly, when sulphur dioxide is dissolved in water, it forms sulfurous acid. So sulphur dioxide is one of the acidic, you can say, oxide. Now, similarly, when we talk about phosphorus, phosphorus is forming phosphorus pentaoxide, which is P4O10. When P4O10, which is phosphorus pentaoxide, is dissolved in water, it forms orthophosphoric acid, which is H3PO4. So simply phosphoric acid can also be said over here. So phosphoric acid again is an acid. Therefore, all these oxides are considered as to be acidic oxides. In neutral oxides, here we find that carbon monoxide is a neutral oxide. Water, which is formed by the combination of H2 with oxygen, it is the then again neutral oxides. So that is how we get to understand the nature of the non-metallic oxides as well, that mostly they are found to be in acidic in their natures. This is the simple representation of how nitric oxide, nitrogen dioxide, and nitrous oxide can be written, and the formulas, as you can see, NO. So there is a triple bond between nitrogen and oxygen. Similarly, the bond formation in nitrogen dioxide can be shown like this, whereas in the case of nitrous oxide, it can be shown in this manner. So how the bond formation and all these things are done and what kind of bonds are involved, you will get to understand when we will discuss the chapter carbon and its compound. So simply when we have to summarize it, we can say that the non-metal, when react with oxygen, they form the non-metal oxides. And this is how we can identify the nature of the oxides. And few of the examples, kindly check the spelling of sulfur. It's SULPHUR and not SULFUR. So carbon dioxide, sulfur dioxide, and nitrogen oxides, they all are the acidic oxides because they are forming acids here. So this is the concept map which may help you in remembering things in a better way. When non-metals are reacting with oxygen, so during burning this reaction will be called as combustion. Some of the non-metals which are reacting with oxygen, they are forming the non-metallic oxides, and few of the examples given here are carbon and sulfur. When carbon is reacting with oxygen, it is forming carbon dioxide majorly. When sulfur is reacting with oxygen, it is majorly forming sulfur dioxide. And please check the spelling of sulfur. Do not write it as SULFUR. It has to be SULPHUR. So this is all about the reaction of metals and non-metals with oxygen, and the different natures of their oxides. And the way how we obtain the nature of oxides is by just dissolving them in the water and then testing them with the help of an indicator, so as to know the acidic or the basic characteristics. So that's all for today. Please revise the whole concept and the content with the NCRT also, so that you are able to correlate and connect with what has been discussed here. So in the next class we will be discussing the next chemical property of the metals and the non-metals. So till then, please take care. Bye. Bye everyone.